In this video, we're going to try to prove the following result, that the absolute value of the integral of a between a and b of f of x dx is less than the integral between a and b of the absolute value of f of x dx. Okay, so we're also going to see what happens when we assume that f is bounded by a certain m. What happens in this case? So the key idea here is that we want to find an upper bound of this integral. And this is a very famous formula that we can use here. Okay, if we are given that a is between minus x and x, okay, so that means that the absolute value of a is less than x. Okay, so we're going to use this one here. We have to choose carefully what we mean by x and what we mean by the absolute value. Okay, and it's clear from here that this is the absolute value of a if we assume that the integral between a and b of f of x dx is treated as a. So here we're going to see what we can do. Okay, so the key idea is that given any function, okay, so we can, because we are given this function that's continuous in this interval a, b, so we can write f of x. Their values are always between the absolute value of f of x and minus the absolute value of f of x. It can't exceed that. Okay, now we're going to use this one here from algebra. Okay, so now we treat x as the absolute value of f of x and a as f of x. Okay, so this one here means that the absolute value, but before we do that, we have to do one more thing. Okay, so because we are interested in the integral, so since all of these functions are integrable because they are continuous, so we can take the integral here. So we're gonna say integrating. Okay, we're gonna get the integral of f of x dx between a and b is bigger than a, b, let's take the minus outside, f of x dx. Okay, and the integral of the absolute value of f of x dx between a and b. Okay, why we had to take for this integral, why did we have to take the absolute, the minus outside? Remember that the integral of lambda f of x dx is the same as lambda a, the integral between a and b f of x dx in absolute value. So think of lambda as being minus 1 exactly. So here we're going to use this formula from algebra. Okay, so now our a is being this one, and x is the integral of between a and b of the absolute value of x dx. So this is equivalent to the same thing here. So this means that the absolute value of this integral is less than the integral between a and b of the absolute value of f of x dx. Okay, so this proves our formula that we need. Now, what happens when f is bounded? If f is bounded, that means f of x is less than m for all x in AB. So that means we have it here. So we're gonna reapply this one here to this function. So we have f of x dx between a and b is less than ab m dx. And since m is a constant, we'll take it outside and we integrate. So therefore, the integral of f of x dx is gonna be less than mb times b minus a. Okay. So if f is bounded, okay, let's say it has some bound here. Okay, let's say this is our AB, so it's bounded by some m. Let's say some m here. Okay, so the integral of f is gonna be less than the area of the rectangle. So this is b minus a times m. Okay, so it's gonna be less than that. So this is the area of f of x dx. Okay, and it's the same thing as so f of x dx is the same as the absolute value of f of x dx, since f is positive. So it means that this area here in red is bigger than the area of the function which is here. Okay, that's what it means exactly. And this proves our formula. Okay, sometimes we have some combination of the two. So we have f and some f and g. Okay, so instead of working with some f, we can work with some g. Okay, so what happens when f of x is equal to g of x sine of x? Okay, so here f of x is g of x sine of x, both functions continuous. Okay, so try to apply this one here and see what you get. Thank you very much.